Alright, okay, so now let's do inequalities now. Let me change it to brush. Okay, so for question 1 now, we have x squared minus, okay, sorry, plus x minus 4 over x squared plus 4 is greater than 1 over 2. So what you can do here is, if you can factorize the bottom and the top and then you cancel out, it will make your work easier. But here you cannot factorize, so let's just cross multiply. So we'll be having 2 into the bracket of x squared plus x minus 4 is greater than x squared plus 4, right? So here we have 2x squared plus x minus 4 is greater than x squared plus 4. So from here now we are going to bring collect like terms. So this x will come here. This is going to form a quadratic equation. So let's just bring everything over to this side, right? So we have 2x squared minus x squared plus x minus 4 is greater than 0, because there's nothing left on that side. So we have 2x squared. Sorry, we have supposed to have just x squared. Because 2x squared minus x squared is x squared. So we have x squared plus x minus 8 is greater than 0. So what we're going to do here is that we are going to try and factorize. I'm looking at it now and I don't think factorization is possible. It is not. Alright, so we're going to solve normally, right? So let me solve it normally here. Solve it normally. That is to say that x squared plus x minus 8 is equal to 0. This is us solving it normally. So I'm using general formula. So a is equal to 1, b is equal to 1, c is equal to minus 8. So from here, our general formula, x is equal to minus b plus or minus root b squared minus 4ac over 2a. Right? So x is equal to minus b, which is minus 1, plus or minus our b squared, which is 1, minus 4, our a is 1, c is minus 8, over 2a. Our a is 1 as well. So x is equal to minus 1 plus or minus, this is 1 plus minus times minus plus. 4 times 5 is 20. So 4 times 8, sorry, and that is 32. 4 times 8 is 32, then we have over 2. So x is equal to minus 1 plus root 33 over 2, or x is equal to minus 1 minus root 33 over 2. So we can see that it does not give us perfect whole numbers, right? So from here now, to get, because most of the time now the issue that comes with inequalities is to know if x is less than this one or x is greater than this one, right? So I'm going to explain it now. I'm going to be explaining that now. So what you do, alright, I'm trying to undo the x. Alright, so what you're going to do now, you're going to draw a number line. We're going to draw a number line. Now this one that is here, if you want to put it as if we factorized it, we can just bring this one to the other side of x, right? So we're going to be having something like this. X, okay, let me just use, let me clean this first. So here we have x is equal to minus 1 plus root 33 over 2. Here we can cross multiply. So we have 2x plus 1 minus root 33, right? Then this is equal, this one is equal to this is equal to 0. Then for the second one, we're going to have 2x plus 1 plus root 33 is equal to 0. So now if we want to express this thing, right, so we're going to have into the bracket of 2x plus 1 minus root 33 multiplied by 2x plus 1 plus root 33. So the way is equal to 0. Yeah, the way we have done it now is as if we factorized it, right? This is what we need. We need something like this to be able to solve. I'm going to go ahead and clean this, please. Alright, so here we are having this. So it looks as if we factorize it now. So we have 2x plus 1 minus root 33 then multiply by 2x plus 1 plus root 33. This is we're going to use this sign that is here. This sign is greater than 0, right? So now it's as if we factorize it. Remember, what we did is that after we solved and got to this point, we noticed that we could not factorize it, so we solved it normally. And when we did that, we got x is equal to 1 plus or minus root, so we got minus 1 plus or minus root 33 over 2, right? And then we express them as this and this. So now that we have expressed them as the both of them, because what we just did is that we cross multiply. So we have 2x equals to minus 1 plus or minus root 33, and then we brought everything to one side, then equal to 0, right? It's just like this. Now whenever you have x is equals to 2 or x is equals to 3, you know, if you want to change it back to a quadratic equation, you just have to bring this one to this side. So you have x minus 2 in brackets x minus 3 is equal to 0, and then you solve and then you get your answer. You get x squared minus 5x plus 6 is equal to 0. You get this back. So the same thing we are doing here now. We are so since we got this, we just changed it to this form here, as if we want to take it back. So now that it is like this, it's as if we factorized it. It is as if we factorized it, but we didn't, right? So this is like a trick. So now I've gotten 2x plus 1 minus root 33 multiplied by 2x plus 1. I don't know, this thing is not looking clear. Let me rewrite it so it is clearer. Alright, so we have 2x plus 1 minus root 33 multiplied by 2x plus 1 plus root 33, and everything is greater than 0. We're using this sign, right? So now what we're going to do is that we're going to put the values of x on either side of the table, right? This place is going to take our 0 value. Then we're going to put the values of x. We're going to put the negative and positive value. This side is going to be the positive side, and this side is going to be the negative side. So very quickly now, we're going to get a value for x. We're going to try to get a value for x. So now from here, this is where we're going to get our value for x, right? So we have minus 1 plus or minus root 33. So now root 33, well, we're trying to do this thing without calculator, right? Now we have to look for what the perfect square is that root 33 is closest to. So now we have root 33 here. The perfect square is closest to, we have root 36, right? Root 36, and then we have the one that it is before, we have root 25. So we can see that it is closer to root 36, and root 25 is what, 5, and root 36 is what, 6. So it means that root 33 is more closer to 6 than 5. So that means if we are looking at it, root 33 should probably be around 5.7, because it is very close to 36. So let's say it is 5.7, so we can use that. So we have minus 1 plus 5.7 over 2. So this is going to be minus 6.7 over 2, and this is going to be minus 3. That's minus 3.35. Yes, that will be minus 3.35. Then if we do for the positive side, minus 1 minus 5.7 over 2. So this will be, sorry, this is supposed to be 4.7. So this will be 2.25. And then this is looking too rough. Let me just clean this space here. Alright, so here now we have so the first one we have minus 2.35, and the second one we have minus 1 minus 5.7. So this is not minus, this is positive, over 2, and this is going to be minus 6.7 over 2, and this is going to be equal to minus 3.35, right? So we're getting these two values. So these two values now, we're going to put them in this our number line. The negative one is going to be a minus 3.35, and the second one is 2.35. So now we're going to check, right? Because we're looking for the values of x that we will put here and we will get greater than 0. So any value of x that we put here that gives us greater than 0, that's going to tell us whether x is going to be greater than this expression or x is going to be less than it, right? So for this one now we have minus 3.35. So very quickly now I'm going to this 1 minus root minus 33, let's express it. So this is 2x, then we have this one we already said is minus 5.7, so this is going to give us minus 4.7 multiplied by 2x plus 6.7, right? Yes, this is greater than 0. So now let's try. We're going to first try a number that is greater than 2.35. now 3 is greater than 3.25, right? So let's put 3 here. So we put 3 here, we have 6 minus 4.7, we have 6 minus 4.7, we have 1.3, and then we put 3 here, we have 6 plus 6.7, we have 12.7. if you should multiply these two, it is going to give you a number greater than 0. So it means that x is correct for any value here. X is correct for any value here. And now for any value here, it means that x is greater than 2.35, right? So we have already gotten one. X is greater than 2.35. Now what we're going to do is that we're going to check for this side too. We will check for the values in this side. Now let's check. This is minus 3.535. Let's look for a number that is less than minus 3.5, because this side is the negative side. So let's go with minus 4. So let's put minus 4 here. 2 minus 4 will give us, 2 times minus 4 will give us minus 8. Minus 8 minus 4.7 will give us minus 12.7. Let's put minus 4 here. 2 times minus x minus 4 will give us minus 8. Minus 8 plus 6.7 is going to give us minus 2.7. When we multiply this, minus times minus will give us plus, and it means that the number that we're going to get is going to be greater than 0. So it means that the values here are also correct. Once you have really gotten these two, then you know that you stop. So that means x is less than minus 3.35. Sometimes the values here will not be correct. Then you check the values here. So if you are checking for the values here, you put this minus 3.35. So we can try minus 2, right? So if we try minus 2, let's just put it here. So 2 times minus 2 give us minus 4. Minus 4 minus 4.7 is going to give us minus 8.7. But if we put minus 2 here, we have 2 times minus 2, that will give us minus 4. Minus 4 plus 6.7 is going to give us what? 2.7. When we multiply, because this one has negative, the number is going to be less than 0. So it means that it is wrong for this place. And I'm very sure that it's also going to be wrong for this place, because we already have 2. So once you have these 2 correct, then you can now solve. So this place is telling us that x is greater than 2.35, but it is less than minus 3.35. But this is not going to be our answer, right? We are going to put it back in the form that we made the question. So this minus 3.35, where did we get it from? We got it from this one here, where we have minus 1.5.7 over 2, right? So we are going to put this thing there, because the question might not be in decimal, right? So we have minus 1 plus or minus, sorry, this is going to be minus, right? Because it was minus that we used to get minus 3.35. So it's going to be minus 1 minus root 33 over 2 is greater than x, right? Okay, yes. And then x is, then the second one is going to be minus 1 plus root 33 over 2. Minus 1 plus root 33 over 2. Alright, so this is how you get the accurate values, to know which one is greater than and which one is going to be less than. Alright, so let's go to question 2. I already spent a lot of time on this question. Let's just go to question 2. Let's go to question 2. Let's go to question 2. Let's go to question 2. So for number 2 now, number 2 is practically the same thing. Okay, but let's just do it so that I can use it to explain again. So x squared minus x minus 4 over x squared plus 1 is greater than 1 over 2. It's greater than 1 over 2. So here we are going to cross multiply again. So we have 2x squared minus 2x minus 8 is greater than x squared plus 1. We bring all these values to this side. So we have 2x squared minus x squared minus 2x minus 8 minus 1 is greater than 0. So here we have x squared minus 2x minus 9 is greater than 0. So let's see if we can factorize. Can we factorize? We cannot. So let's use our general formula. Our a is 1, our b is minus 2, and our c is minus 9. Our c is minus 9. Alright, so now let's put our values. So we have x equals to minus b, that's minus times minus 2, that will give us 2, plus or minus. We have our roots. We have b squared, which is minus 2 squared, which is 4, minus 4ac, all over 2a, which is 2 times 1. Alright, so here we are going to have x to be equal to 2 plus or minus roots. Here we have 4, minus times minus is plus, 4 times 9 is 36, 4 plus 36 over 2. So x here is equal to 2 plus or minus roots 40 over 2. Right? So this is x is equal to 2 plus or minus. Now we're going to look for the same thing again. We're going to check. Let's just convert to decimal from this point so that it is less bulky. So there we have root 40. Let me put it in the middle. We have root 40. The closest this into it is root 36, and the next one is root 49. This shows us that because 40 is closer to 36, so that means root 40 will also be closer to will also be closer to 36. This is 49, right? So we can just say the difference between them is 4, right? And root 4 is 2. So let's just say that this one is 6, this is going to give us 7. So let's say that root 40 is either 6.2 or 6.3, right? Let's just use 6.3. You can decide to use 6.2, you still get the same answer. It's just the same idea. We're just trying to know which one x is greater than and which one x is going to be less than, right? Or if x is going to be less than the both of them or greater than the both of them. So let's say x is 6.3, right? So let's say x is 6.3. So here we're going to have 2 plus 6.3 over 2. X is equal to 2 plus 6.3, which is giving us 8.3 over 2, or 2 minus 6.3 over 2. Here x is equal to 4.15, or this is going to give us minus 4.3, which will give us minus 2.15. Now I've got these are our values for x. Let's bring it back as if we want to get the quadratic equation from the beginning. So this is going to become here, and this one is going to come to the other side of x. So we have x minus 4.15 in brackets is multiplied by x plus 2.15, and this is going to be, we're going to use this sign that is in this place, that is greater than, so it's going to be greater than 0. Alright, so let me clean the first part. So here now we have x minus 4.5. Let me just rewrite it. So we have x minus 4.15, and here we have x plus 2.15. This is greater than 0. So we're going to draw our number line now. We draw a number line. This is 0. This is the positive side. So we'll put we're going to put 4.15 here, 4.15, and this is minus 2.15. We're using the values of x here, and it's positive here. We're not using this one that is negative. So it's positive here. So we're using 4.15 and 2.15. So now we're going to look for a number that is greater than 4.15. So let's carry 5. So we carry 5 here. Let's see if it's going to give us a number that is greater than 0. So 5 minus 4.15 give us 1.15. Then we have 5 plus this will give us 7.15. When you multiply this, it's going to give you a number greater than 0, right? It's going to give you a number greater than 0. So that means this place is correct. Whenever, because this sign is greater than 0 here, so whenever we take a value of x and the answer gives us a number that is greater than 0, then that means that place is correct. Assuming this place was less than, if this place was less than and then we got a number that is greater than 0, then that means this place is going to be wrong. So just understand that. So let me just cancel this. So I've gotten one of them already. So the second one, let's check for this side. So we're checking for this side now. Let's take minus 3, because minus 3 is smaller than minus 2.5. So if we put minus 3 here, we're going to have what? Minus 7.15. Then we put minus 3 here, we're going to have minus 1.15. And this, when we multiply it, minus times minus is going to give us positive. So it means that this place is greater than 0. Even if it is 0.1, it is greater than 0, right? So that means this place is also correct. And I can tell you for a fact already that this place is going to be wrong, right? It's going to be wrong. But let's prove it. Let's take a number here. Let's say minus 1. If we put minus 1 here, we're going to have minus 5.15. And then we put minus 1 here, we're going to have 1.15. When we multiply, minus times plus will give us minus. And since it's already minus, it's going to be less than 0. So, right? So that place is wrong. So let's try for this place now. Let's take 3. Let's take 3 because 3 is between 0 and 4.5. So if we put 3 here, we're going to be having what? Minus 1.15. But if we put 3 here, we're going to be having 5.15. Minus times plus minus less than 0. So this place is wrong. So now the place that it is correct is if x is greater than 4.15. That's if x is greater than 4.15, and if x is less than 3. If x is less than minus 2, sorry, if x is less than minus 2.15, right? So now which one is 4.15? 4.15 is this one that is here. That's 2 plus root 40 over 2. So let me just clean this place. That's 2 plus root 40 over 2. So we're going to put it now. So x is greater than 2 plus root 40 over 2, and x is less than 2 minus root 40 over 2. So let's put this in number line. So we'll put our x here. So for this one, that's 2 minus root 40 over 2, and x is greater than 2 plus root 40 over 2. And this is our final answer. So you can see this is very, very simple, right? It might take a little bit of time, but it is very simple. So let's quickly do number 3, because they already told me that the laptop wants to die. But let's go to number 3. So we have number 3 now. So we have the modulus of x plus 3 is greater than 6. Now whenever you have a modulus like this, your a value is going to be greater than minus b, or a is less than b. Your a value is going to be greater than minus b, or a is less than b, right? This one that is here is our a, and this is our b. So we're going to say x plus 3 is greater than minus 6, or x plus 3 is less than 6. So we're going to bring this 3 to this side. So x is greater than minus 9, or x is less than 3, because 6 minus 3 is 3. Alright, so you guys should be able to do number 4 on your own before I want to end this video before the laptop dies.